Welcome to our next video of Stat 212. In this video, we're going to talk about stratification, which is something that we commonly do in a lot of observational study formats to kind of check, how balanced our groups are, and kind of as an ad hoc way of judging internal validity in the context of an observational study. So whenever we do observational studies, we're naturally going to have a lot of confounding threats. And that's because I'm not controlling the environment. I don't have the power of assignment. All I can do is just observe what happens for possible associations between variables. So something that I might want to do kind of after the fact is to look for possible differences and possible confounders to be aware of. And if I do that exploration of confounders and I see that some possible confounding suspects turn out to be well balanced between my groups, then that kind of improves my internal validity. In other words, that even though it's an observational study, I might still have kind of a hint of causality, at least a hint that maybe I should study this further and see if I can find more evidence of this strong association that might imply a possible causation. So again, we do observational studies when experiments are difficult to do, or maybe I just don't have the funds to do an experiment. Observational studies involve data that's often a lot easier to collect or a lot easier to find. Or just, again, when it's not possible to do an experiment at all. So if I can stratify my data, stratification would be kind of this way to break up my participants, my groups, into smaller subgroups of similar type people and see if this comparison still holds. So it's this idea that maybe my two groups, maybe if I'm studying the effect of smoking, for example, and maybe I don't assign people to be smokers or non-smokers, I just find people who happen to smoke and people who happen to not smoke. Well, there might be a lot of other differences between smokers and non-smokers besides just the smoking. So I may not really be doing a true apples-to-apples comparison without looking at these other possible differences between my two groups. But maybe I can identify, smokers and non-smokers of the same general age, the same general, health status, the same other characteristics. And so by comparing smokers and non-smokers who happen to have other shared characteristics, then I am making a more apples-to-apples comparison than if I just take all the smokers versus all the non-smokers and ignore any other possible differences between these groups. So as an example, we do actually have a smoking example here. This is some very old data from the UK. It was taken between 1972 and 1974 with some follow-up surveying much later, I guess about 20 years later. And so one observation that was made was, there's many variables collected in this particular survey, but one of them was whether or not the participants were smokers or not. And by contacting these people 20 years later, the polling firm involved was able to see what percentage of the smokers and what percentage of the non-smokers were still living after 20 years. And one seemingly odd observation here is that people who smoked were actually more likely to be living than people who didn't smoke from the 1970s. So it leads to this kind of question of, do people who smoke, are they actually living a longer lifestyle? Are they actually more likely to stay alive than people who don't smoke? But that would be a very faulty conclusion to make without some further exploration, because people who smoke may be different than people who don't smoke in a lot of different ways. Well, one variable of interest, one way that we can stratify our data here is by looking at the age of people in each group. In other words, do we see smokers in the same proportions across all age groups or not? And sure enough, this is data from the 1970s. Smokers tended to be younger in the 1970s. We don't really think of that so much now because smoking is kind of, phasing out in a way, and now, it's more likely that older people are smoking and younger people aren't. But back in the 1970s, it was more younger people who were smoking than older people. And so we can see that here in this graph on the right, that if I break up my data into kind of these, I don't know if this is like oops, I have the wrong thing on there. I'm not sure how large these brackets are. They might be about 10 years wide. That if I break up my participants into these 10-year age brackets and I look at the proportion of people who are smoking, it's definitely the younger brackets that have higher proportions of smokers. And these two older brackets from about 70 to 90 here have much lower proportions of smokers. Well, if I look at and kind of mix that with the percent of folks who died after 20 years, you're going to notice, quite logically, that older folks are more likely to die in the next 20 years than younger folks. And so what I need to do is stratify by age and compare the percent of people who died to see if there's a difference. So if I do this kind of apples to apples comparison of smokers versus non-smokers in the same age bracket, what do I find? And sure enough, there's a higher percentage of smokers dying compared to non-smokers in almost every age bracket. There are some small exceptions. Once we get to the 70 plus group, smoking seemed to matter very little in terms of percent dead. Even the 60 to 69 group is actually the non-smokers that had the slightly higher mortality rate. But then in pretty much every other bracket, with exception to 30 to 39, we see the smoking group with a significantly higher percentage of mortality, at least for this 40 to 60 group. This is where we definitely notice a difference. Here, the differences are pretty much negligible, as well as here, the differences are pretty much negligible as well. So this kind of throws a wrench into that original comparison where I might be tempted to say, the non-smokers have a higher mortality rate than the smokers. But when I control for age, that possibility more or less disappears, where either the difference is pretty negligible or it's the smoker group that has the higher mortality if I stratify by age. All right, so let's go ahead and practice here. We're going to read two different prompts, and we're going to identify which type of observational study is being described here, and what other variables the researchers should consider collecting and stratifying by if they'd like to identify a possible causal link, or at least explore that possibility. So here, this is a survey conducted to college students asking whether they eat dinner at approximately the same time every day. The survey also asks how many hours of sleep these students get per night. The survey finds that students who answer yes to eating dinner at the same approximate time of day are also getting more sleep per night on average. Okay, so what kind of study is being conducted here? We seem to be collecting data at a cross-section. In other words, we're collecting both variables at the same time. So this would be a cross-sectional study. That's commonly what we're going to see with surveys. That, not all surveys are necessarily cross-sectional, but they commonly are. But the central idea here is we're collecting this data. We have data at a cross-section. It's data from the same period of time. What other variables should the researchers consider collecting and stratifying by? Well, there's a couple of things I can think of, but I would challenge you to kind of ask this question first. In what ways could people who eat dinner at the same time versus people who don't eat dinner at the same time, are there any other differences that might explain differences in sleeping habits? Do you think it's the dinner eating that is the central cause, or is the dinner eating just associated with other things that might explain differences in sleeping habits? So go ahead and think about that first. But since the video, I will go ahead. So one thing that I definitely think about is work schedule. So does this student have another job outside of school? You might just more generally think about busyness of schedule. Because people might be putting off dinner because they're just really busy. And because they're really busy, they're just not getting as much sleep. So in other words, what I'd kind of hypothesize here that we should look at is, does busyness cause like chaotic eating and less sleep? Which would kind of, counter this possible causation of, is it the chaotic eating that causes less sleep? I would question that. I think that this might be a better explanation. Again, I don't know. If I don't have data to back it up, it's just a theory. but it's something that I would kind of poke at with this study before I make this very, very, shaky causal claim. I think that's probably not a great claim to make just from this data alone. Something else that I would kind of point out is that some students still live with parents or family, and that those students are probably more likely to have dinner at a regular time because they're not necessarily responsible for making the dinner, right? They just eat on their family schedule, which might be more regular. And those students might also just be getting more sleep. So, I'm just going to say living situation. Whether you're living with family, living in a house, living in an apartment, living in a dorm, those are all things that might affect both your eating schedule as well as your sleeping schedule. I'm sure there's a lot of other things you could think of as well, but those are two that definitely come to mind for me that would kind of question this, this link right here. I don't necessarily think this is a good link to make without stratifying for some of these other ideas over here. Okay, here's another example. A group of cardiologists identified patients with diagnosed heart disease. The researchers then looked back at medical records to determine which were prescribed a particular aspirin that the researchers suspected might have links to heart disease. They found a clear association. Okay, so here the researchers are first identifying a result. They're looking at people with heart disease. Then they're looking back at medical records to try to determine what these people have in common. So, what is it about people who have heart disease? What might they have done that could have caused that? So this is a case control study in that case, because what we're doing is starting with the result, we're starting with the response, and then we're looking back for a possible cause after the fact. So one thing the researchers noticed is that people who were taking aspirin were more likely to have diagnosed heart disease. Could this be a possible cause? In other words, does that mean that aspirin might be a risk factor for heart disease? Does taking more aspirin then make you more likely to get heart disease? Should I consider that? And I think there's several things that we could keep in mind, and that is, what is it that people who take aspirin might have in common that might also be related to having heart disease? In other words, we're trying to fill in this blank. What might increase your chances to take aspirin and also increase your chances for heart disease? So aspirin is something that you would take usually if you have kind of pain. I should probably get myself out of the way here. I'll put myself up there. Okay. So one thing that I would think about would be weight or other health factors. So there's a lot of things we could kind of mention here. So weight, health factors in general, maybe family history of different genetic issues. Right, so these are things that might be related to why you need to take aspirin in the first place, is you're just not in good health for whatever reason. And because you're not in good health, you might also be more likely to have heart disease. So it's not necessarily the aspirin that's causing the heart disease. It could be. Like this is a possibility. But I don't know that yet from this data alone. It's just a question mark. And there's several other things that could also be explaining this relationship. Aspirin just could be associated with something else that's really the cause here. All right, so we'll stop there.